or this weekend, you watched a video with Miss Cronky talking, right? And you wrote down these steps, okay? You're going to factor the denominator. You're going to write the given problem using the number of fractions, however many factors you have in your number in your denominator. Determine the number of fractions that you're going to decompose this into. The factor is linear. Your numerator is constant. If there's a repeated factor, you have to include all of the versions of that repeated factor. And if the factor is quadratic, then your numerator is linear. Okay? Setting up the problem is what you practice, or what the notes were over. That's what you practiced just now. We'll check to make sure you're right. What we're going to do today is actually solve for the A, B, C, D, E, F, G that you've been writing. Okay? So what we're going to do from what you've set up is we're going to multiply everything by the common denominator. That way we get rid of all the fractions. Okay. Then we are going to solve for our constants. There's two different ways. I'm going to show you how to do this. We can either plug in, here I'll move this up. We can either plug in the zeros of the denominator to find values, or we can compare coefficients of like terms and set up a system of equations. Once you solve for A, B, C, D, E, F, G, etc., hopefully it's not that many, then we can actually write out the decomposition. Okay, so from what you have written, we're going to solve for the A and B and other letters, and then rewrite it, and so you have a number over a denominator instead of a letter over a denominator. So I'm actually going to go, I'm going to go a little bit out of order than how I wrote them up here. But this one is the one we're going to start with, at number 1. Okay. So I already gave you what the denominator factors to. That has to be your first step, so you know how many fractions to break this up into. Okay, so I already told you that this factors to x plus 2 times x plus 4. So Connor, what is your breakup of this fraction?
X plus 2 plus b over x plus 4.
What did you say?
A over x plus 2.
A over x plus 2.
And then plus b over x plus 4.
Okay. Do you agree with Connor? Okay. If you have A over x plus 4 and B over x plus 2, that is fine. Just when we're doing the problem, our A's and B's are going to be different. They're going to be switched. That's a better way to say it. They're going to be switched. But when we get to the end, we're still going to get the same answer. So if it's going to confuse you, go ahead and switch your A's and B's to the same as mine. If you don't think that'll be confusing, you can keep with what you have. Okay? So, this is where we go from here. You're going to take the entire equation and multiply it by your common denominator. The LCD, it's going to be whatever this denominator is right here. So, x plus 2 times x plus 6.
4.
4. Yep.
And do you want us to write it like that, or do you want us to write it like the x represents?
I would suggest writing it like this. Okay? So this is going to get rid of any fractions. Okay? So x plus 2 times x plus 4 cancels out with this denominator, so we're left with x plus 8. Here the x plus 2's cancel out, and a is left to be multiplied to x plus 4. And here the x plus 4's cancel out. And so b is left to be multiplied to x plus 2. Does everyone understand what just happened there? All right. So when we have nice linear denominators that don't repeat, we can simply plug in numbers to x to solve for our variables. So what number would make this factor 0? -4. So what we can do is we can plug in x equals -4 into this equation. So we can figure out what b is. Okay? So what we get is -4 plus 8 equals a times -4 plus 4 plus b times -4 plus 2. Conveniently, this is 0. And what's 0 times a? 0. So what we have is 4 equals -2b, which makes b what? Then we can do the same thing with the other factor. What would make x plus 2 disappear? We can plug in -2. If we plug in -2, what's -2 plus 8? 6 equals a times what's -2 plus 4? 2 plus -2 plus 2 is 0, so we have plus b times 0. Okay, notice how I did some of the work in my head. That is okay. I at least need to see this. What's a? A is 3. So by strategically picking numbers to plug into x, we have solved for a and b. So now we can come back to the beginning, and our partial fraction decomposition, we can just replace a and b. So instead of a over x plus 2, we have 3 over x plus 2. Okay? And since b is negative, we can simply write -2 over x plus 4. If you write plus -2 over x plus 4, I'm not going to be upset, but it is possible to write it like this. Okay. What did we just do? We just took a fraction and we broke it up into, in this case, a subtraction problem. If we went through the process of getting common denominators to actually combine these two fractions, we'd get back to where we started. Okay, so we're kind of working backwards from adding and subtracting fractions. Questions? Kind of a nice change of pace, isn't it?
Yes.
Gabe's excited. At least one person is excited. Okay, the next one I want to do is 5x squared. This one. So this is number 3 for your warm-up. Okay. Is everyone okay with it the denominator factoring to x times x plus 1, the quantity squared? Yes. Okay. Excellent. How many fractions does it get broken up into? 3, because there's 3 factors. Okay? So let's see. Will, what did you write down for that?
It should be a over x plus b over x plus 1 plus c over x plus 1.
this what you said? Okay. Do you agree with Will?
No.
Darby?
First x plus 1 should be squared.
Okay. One of them needs to be squared. So if we have repeated factors, there needs to be, each factor needs to be represented. So x plus 1 needs to be represented, and x plus 1 squared needs to be represented. It doesn't matter the order in which you put them, okay? So if you put x plus 1 squared first, that's not going to bother me, okay? But if we just left it as both of them x plus 1, we'd be able to add those two fractions together to just be 1, okay? So if we think of like going the other way and making a common denominator, without x plus 1 squared, it wouldn't be in our common denominator. So both of them have to be represented, okay? So are we okay here? All right. Okay, so we are going to multiply by the least common denominator. Our least common denominator is the same as this denominator, so we're left with 5x squared plus 20x plus 6. Okay. A, what will A be left to multiply by? I didn't really get that plus in there, did I? Okay. What about B? What does B get multiplied by after we cancel some stuff out? I would leave it as x times x plus 1. Yes, it's x squared plus x, but I would leave them separated out for right now. And then C is only left with x. Okay. Now we need A, B, and C. Okay? From here, we can plug in numbers to figure things out. All right? Sarah, what's a good number to plug in to help us out? -1. -1 makes this go to 0, and so that's going to eliminate some variables for us. So x equals -1. All right. So if we plug in -1, we have 5 times 1, 20 times -1, and then plus 6. If we plug in -1, -1 plus 1 squared is 0, so this is a times 0. I'm not going to write it down. Plus, -1 times 1 is 0, so this is b times -1 times 0. That goes to 0. So really, we're just left with c times -1. Okay. So let's see, 5 minus 20 plus 6 is -9. -9 is -c, so c is 9. Okay. Amanda, what's another number we can plug in? 0 would be a good number to plug in because it would make this factor disappear. All right. So if we plug in 0, what happens over here on the left side? What are we left with? 6. Okay. And then we would have a times 1 squared plus b times 0 plus c times 0. So those will disappear. So a is 6. Okay. So we have all of our variables. We still need to find b. However, we've used all of our factors to make this appear by plugging in numbers that would make those factors 0. Okay. If this happens, okay, we've strategically picked numbers to plug in to make factors go to 0. Okay. So we can plug in a number that doesn't make the factor go to 0 as long as we have all of the other variables. We have A, we have C, all we need is B. So we can just plug a nice number to plug in for X. What would a nice number be? 1 would be a nice number. Right. And if we plug in 1, we get 5 plus 20 plus 6 equals, we know A is 6 times 2 squared, because 1 plus 1 is 2, plus B times 1 times 2, plus C is 9 times 1. Okay? So we plugged in X is 1, we plugged in C is 9, A is 6. I'll let you go ahead and do some algebra for me there. Oh, it is actually time for lunch. So what I'll have you do is when you come back from lunch, you're going to tell me what P is. So as you file in, you can, if you haven't done the algebra already, you can either stay and do it now or do it when you get back while we wait for people. All right? So I'll write the answer when you return. All right, can someone tell me what they got for B? -1. So when we go to write our answer, we have, let's see, A over X plus B over X plus 1, so I'm just going to write -1 over X plus 1, plus C over X plus 1, the quantity squared, so plus 9 over X plus 1, the quantity squared. There's our partial fraction decomposition. Okay. We broke our fraction apart. Hence the word decomposition. Any questions so far? So now let's go to this second one that you did. When you factor an x out of the denominator, x squared plus 4 cannot be factored any further, can it? Okay. So technically, how many factors do we have? 2. Okay, so we're going to break this up into 2 fractions. So Finn, what did you write for yours?
I had A over X plus B over X squared plus 4.
This is what Finn wrote. Do you agree or disagree? Caroline? Okay, Caroline asked, wouldn't it be bx plus c over x squared plus 4? Then what do you think about that?
I don't know, that's what I was thinking it could be.
Okay, so since our denominator is quadratic, then our numerator has to be linear. Okay, whatever our factor is, our numerator is 1 degree less. So if we have a linear denominator, our numerator is just a constant. If we have a quadratic denominator, our numerator is linear. Okay? Yes.
And so that's a quadratic only, like if it can't be broken down more, because like we had the quantity x plus 1 squared, and that ended up being a constant.
Right. So since this is a linear factor that is repeated, it is still considered linear and as a denominator, and so we've just put a constant for the numerator. So that's an important difference to realize. This is still a linear factor even though it's repeated, so we put the constant in the numerator. This is a quadratic factor, and so the numerator needs to be linear. Okay? Is everyone okay with how we have this set up here? Okay. So we are going to multiply the entire thing by x times x squared plus 4. Okay? That is our LCD. The LCD is always going to be this denominator right here. Okay? So when we multiply by that LCD, it cancels out completely with this denominator. Okay. A is left to multiply to what? X squared plus 4, because these x's will cancel. And then the quantity bx plus c, x squared plus 4's cancel out, is being multiplied to x. It is important that you put that linear factor in parentheses. Okay, because all of it is being multiplied to x. Okay, now here's the trouble when we work with partial fraction decomposition and we have a quadratic denominator. If we try to do the method from before, where we pick values to make our factor 0, we can do that here. We can make this go to 0 and solve for a. But how do we make this go to 0? We can't with real numbers, right? We want to stick with real numbers, okay? So that method is not going to work when we have this quadratic factor, okay? So let me show you an alternate method that we can use, okay? The alternate method involves multiplying everything out. So we can distribute the a through here, and we can distribute the x through here. And then what I'm going to do on the right side is I'm just going to rearrange. I'm going to rearrange so that ax squared plus bx squared are kind of together since they both have an x squared. And then I'm going to write plus cx, and then I'm going to write plus 4a. Okay. Right now we have two equations that are equal. We have a quadratic equals a quadratic. If these two equations are equal, then what?
They have the same graphical complexity, right?
I guess I don't know what you're trying to say.
If they're equal, then they're going to be the same equation.
Okay, so that right side should be 3x squared plus 4x plus 4, right? Well, if I have ax squared plus bx squared, that needs to be the same as what? 3x squared, right? So we can write that a plus b has to equal 3, because the coefficient of x squared should be the same as this coefficient of x squared since we have equal equations. Okay? Okay, what about 4x? Has to be cx. What is c? C has to be 4.
This way looks so much easier than the other.
What about our constant? 4 has to equal 4a. Okay? Now, Jackson, you're really excited about this method. Here's my warning. Okay? Why are we doing partial fractions in this chapter? This doesn't make sense. Okay? If you... So
They're not so easily solved.
okay, if this was like... And technically we still kind of have a system of equations, but if you have lots of terms, you could have a system of equations here, okay? So you might have 3 variables and 3 equations that you would have to solve. And then it wouldn't be quite It might be more complicated than the other way, okay? Sometimes we get lucky, sometimes we don't, so you have to be kind of careful about when you choose to use this method if you do have the choice, okay? But this one's kind of nice. A equals 1, C equals 4, and if A plus B is 3, B is 2. So our partial fraction decomposition, it's a really fun expression to say really fast, is 1 over x plus 2x plus 4 over x squared plus 4. A over x plus bx plus c over x squared plus 4. Questions? You ready for our last example? Okay. So let's see, we get out of here at 1:40. We're going to do this last example, and then hopefully you have time to do one problem before you leave. Okay? That's my goal. All right, Henry, how did you set this one up?
So setting up.
You want to tell me what you're writing down?
I had x squared plus 2 to quantity squared to 1 fraction.
Okay.
And then to the other one.
All right, so we have a repeated factor, so each of them have to be represented. What do you have in your numerators?
And b.
A and B. Okay, so I'm going to write AX plus B and CX plus D. Okay. Since we have quadratic denominators, our numerators need to be linear. Now remember, we only have quadratic denominators if your quadratic factor cannot be broken up. X squared plus 2 cannot be factored. What do we multiply by? Jen, what do we multiply by? Great. X squared plus 2 squared. So we have 8x cubed plus 13x equals, remember to put ax plus b in parentheses. Only one of the x squared plus 2's cancel, so there's still one left over. But in the last fraction, all of the denominator canceled, and we're just left with cx plus d. All right, since we have quadratic factors, our only option is to do the method from before where we compare coefficients. That's what I like to call it. All right, so what are we going to have to do with that right side? Huh? Right, we're going to have to multiply that out, right? So we're going to have ax cubed plus 2ax. So that's first. So a there. And then bx squared plus 2b plus cx plus b. Technically, you wouldn't even have to reorganize the right side, okay? But it may help with everything that you have to keep track of. Okay, so first let's look at 8x cubed. And I'm going to find any other x cubed over here. What do we know? A equals 8. Okay, we're just going to compare coefficients. Now, I don't have an x squared on the left side, which means what is its coefficient? 0. Okay, and then I'm going to go find all of the x squareds over here. Is it just b? So 0 equals b. Cool, we have two of them taken care of. All right. Then we have 13x. So I'm going to find anything with an x. Okay. So 13 needs to equal 2a plus c. And then do you see a constant on the left side?
No, so 0.
0 is our constant on the left side. So 0 needs to equal 2b plus d. We have 4 equations and 4 variables. It sounds intimidating, but it really isn't, right? We already know a equals 8. So what does that make c?
-3.
And if we already know 0 equals b, what is d? 0. It's okay to get a 0 in this case. So our partial fraction decomposition is ax plus b over x squared plus 2 plus cx plus d over x squared plus 2, the quantity squared. So I'm going to go ahead and make this minus. Okay. If we had a d value, we'd want to leave it as negative 3x plus d. But since d is 0, we can go ahead and write that as subtraction instead. All right, we are in here until 140. It is currently 132. So you can reference your gold sheet or you can reference this right here. But I need you to try to get through 2 problems before you leave. Okay? I don't know if you looked at the board, but tomorrow we have a quick quiz over partial fraction decomposition. That means you're going to come in here, I'm going to entertain questions on the homework, and then I'm going to give you a short quiz with 3 problems that you need to do on your own. Now, I'm not necessarily going to grade these to put in the grade book, but we needed to determine whether you know partial fraction decomposition tomorrow or not. That way we can figure out how to fix it before Friday's test.
Equals 0. And then you know b is 0.